So this week we are into chapters 3 and 4 of your textbook. Chapter 3 is focused on the different kinds of claims that we can make in research, and in particular the different kinds of claims that we can make depending on the type of research design and the type of methodology that we're using. And then chapter 4 is focused on ethics. So how can we conduct research in a way that is ethical? And a really sort of simple shorthand way to think about that is we want to reduce harm to participants. In fact, we really want no harm to participants. We want no harm to communities. We want to engage in no harm to the extent possible to all individuals who might be impacted, either directly or indirectly, by the research that we're conducting. Of course, in the field of psychology, where we're studying how people think and behave, this can be tricky because we're often studying difficult topics that might be sensitive for participants and for communities, especially if we're making generalizations about communities based on a sample of participants. And so these topics often relate to trauma, substance abuse, potentially criminal behavior, psychological disorders, stereotype, racism. So a lot of issues that can be very emotionally charged or could potentially be triggers for individuals who have experienced trauma in their life or who are going through something that's challenging or difficult. And so how can we conduct research in a way that helps us to take care of all of the individuals who might be impacted by the research that we're conducting? So the first concept that I want to review is the concept of variable. What is a variable? In your textbook, a variable is defined as something that varies, which means that it has more than one level. So we can think of age. If we measure age numerically, if we're looking at a lifespan, age might have 80 levels if we're thinking of each year as a level, or depending, again, if we're defining age in terms of average lifespan, we can think about each year as a level. But we might also categorize age in terms of stages of development, in which case levels might include infancy, early childhood, middle childhood, late childhood, adolescence, emerging adulthood, young adulthood, middle adulthood. And then we've got 3 stages in the field of psychology of older adulthood: young old, old, and older old, which I like to think of as like, I don't know why we are continuing to develop so many categories of older adulthood, but the older old stage of development often makes me think of like, dang, you're old, but you made it. Both of my grandmothers lived to be into their late 90s, and my grandmother lived to be 99, so I always think like, you did it. So that's how your textbook defines variable, something that varies, right? So, and vary just means like something that can change. Another way to think about variables, if you're trying to identify what are the variables, is a characteristic that can be measured. So a variable is any characteristic that we can measure. Okay, so that's another way to think about variable if you're trying to really like have a concrete understanding about what it is when we're talking about variables. And so if you're looking, for example, at the relationship between self-esteem and academic achievement, if you're looking at the relationship between those two, you're looking at the relationship between 2 variables. Self-esteem, it's a characteristic that we can measure. Academic achievement is a characteristic that we can measure. And both of those can vary. You can have high or low self-esteem. You can have high or low academic achievement. And the way that you measure each of those variables will determine how many levels each of those variables will have. Something else that I wanted to highlight and emphasize is the idea of research, the 3 claims of research. We can make a frequency claim, an association claim, or a causal claim. A frequency claim is it's usually a description about the frequency of a phenomenon in the population. An association claim is usually a description of a relationship between variables. So the key word for association is relationship. And key words used to describe relationships or associations would be like a link, a connection, an association, a correlation. So when we're talking about association, we're really talking about correlations, or in some cases, if we're looking at categorical variables where we don't have like numerical ways to measure them, we might specifically just refer to the relationship or association without using the word correlation. But whenever we're talking about a correlation, we're definitely talking about an association and nothing more. And the third type of claim is the causal claim. And so a causal claim is when we're referring to one variable having a direct causal influence on another variable. The first variable would fundamentally and directly change the second variable. And so you might have heard the term in statistics, correlation does not imply causation. So if we know that there's a correlation between two variables, it does not mean that there's a causal relationship. And so an example I like to use is that there's a known correlation between ice cream sales and shark attacks. There's a positive correlation between those two variables. As ice cream sales increase, shark attacks also increase. And if you remember from statistics, a positive correlation, it doesn't necessarily refer to increase. A positive correlation just means that two variables move in the same direction. So either they increase together or they decrease together. So a positive correlation could also refer to the flip of the relationship that I just described. As ice cream sales decrease, shark attacks decrease. Now, would we say that ice cream sales are causing shark attacks or that shark attacks are causing ice cream sales? No, that doesn't make any sense, right? But in fact, there is a correlation there. They both increase and decrease together. That's a positive correlation. Why might ice cream sales and shark attacks be correlated with each other? Well, there's a third variable in there, and the third variable is season or time of year. So ice cream sales increase in the summer. Guess what else increases in the summer? The frequency of shark attacks. Why? Because more people are in the water. So people are buying ice cream because it's hot, and also because it's hot, people are in the water. So we see an increase in both variables. But of course, one does not cause another. An example I like to use, and this is a real example that's fundamentally influenced the education system in North America for several years. In the 70s, there was a research documenting a positive correlation. So again, two variables that move in the same direction, so are associated with each other, a positive correlation between self-esteem and academic achievement. So as self-esteem increases, academic achievement increases. As self-esteem decreases, academic achievement decreases. And policymakers were very excited about this finding. They said, that's great. All we need to do then is to increase student self-esteem and their academic achievement will go up. But the problem with that interpretation is that policymakers were drawing causal conclusions based on correlational data. Is it the case necessarily that self-esteem is causing academic achievement? Couldn't it be the opposite? Couldn't the reverse be true? Couldn't students be feeling better about themselves because they're achieving academically? But policymakers interpreted the nature of the relationship as self-esteem causing academic achievement. And so throughout the United States, there was a strong push towards curriculum that increased self-esteem in students with the hopes that that would ultimately increase academic achievement. And guess what happened? Nothing, because there's no causal relationship there. Self-esteem, in most cases, does not have a direct causal influence on academic achievement. They're related to each other, but they're related to each other because of multiple kinds of causal factors that weren't measured in that original study that are related to both self-esteem and cause both self-esteem and academic achievement. For example, background demographic variables, like what's going on in the family, socioeconomic status, whether families are able to spend time together, whether students feel support and are specifically supported in their academic endeavors. That kind of support can also have an impact on an individual's self-esteem. So that was an example in which policy decisions were based on an erroneous interpretation of correlational data. And a third example, just to really drive the point home, is the example of happiness and exercise. So there's quite a bit of evidence showing, again, a positive correlation between happiness and exercise. As happiness increases, exercise increases. Does that mean that the happier you are, that's going to cause you to exercise more? Well, not necessarily, right? Exercise can also cause happiness, or there could be additional variables that are causing both happiness and exercise, which is why we see a correlation or a relationship or an association between those two variables. So in the PowerPoint slide handout that I provide for you, so you can take notes as you're reading through your textbook and as you're studying the material, I emphasize that these three kinds of claims, frequency claims, association claims, and causal claims, they're also associated with three primary goals in research. The frequency claim is really associated with a goal for describing, just simply describing what's going on here. What's the frequency of this phenomenon? How prevalent is it, right? The goal of association claims and research in which we can make association claims is really about predicting. If I know that ice cream sales and shark attacks are correlated with each other, then they also predict each other. When ice cream sales are increasing, that predicts an increase in shark attacks, and vice versa, right? As academic achievement is increasing, that predicts an increase in self-esteem. It predicts, but it doesn't necessarily identify causal relationship. It doesn't necessarily explain. So the goal for the third kind of claim, the causal claim, is really about explaining what's causing this. So we know that this is a phenomenon. We know that this phenomenon predicts this other phenomenon, that these two variables are associated with each other. But what's explaining that relationship? Why? What's causing it to happen? What's the nature of that causal relationship? And the only way that we can really be clear about a causal influence of one variable that's causing a change in a second variable is if we have carefully controlled experiment in which we have independent variables that we are manipulating and dependent variables or outcome variables that we're measuring. And if you're uncertain about what I'm talking about, read through your textbook, read through chapter 3, because it defines independent and dependent variables for you. And the other important thing about an experiment in which we can really address causal claims is that we're randomly assigning participants to the different levels of the independent variable that we're manipulating. Now, there are just a lot of psychological constructs that we cannot study using that type of a controlled experiment, because we cannot manipulate independent variables for many of the phenomena that we study in psychology. It would be unethical to do so. For example, if we wanted to examine a causal influence of alcoholism on well-being or depression, it would not be ethical for us to experimentally manipulate alcoholism and to randomly assign participants to either be alcoholics or not. So many of the constructs that we study in the field of psychology cannot be manipulated. And for that reason, it's often difficult for us to draw causal conclusions based on research in those areas. So it's important to be aware of that, because it's actually human nature to infer causality, to try to explain and make those kinds of causal connections. But it might cause us to develop intervention programs that are ineffective. It might cause us to invest funding into a program that will ultimately have no impact. It might cause us to implement medications or therapeutic techniques that are ineffective. And so we have to be critical thinkers about not just the methodology that's being used in research, but the kinds of conclusions that are being drawn based on that methodology. And so this Introduction to Research Methods course is a really important step in helping you to have those critical thinking skills, so that when you're out there and you're a professional, regardless of the area of your profession, you're able to discern what is considered valid, rigorous research. Are the claims accurate? And what kind of research is more fluffy? What kind of research is more problematic? And journalists, they like headlines, so they'll jump to conclusions. And in many cases, journalists will jump to conclusions that researchers never intended. So when you're reading media reports, studies show, it's important to be able to think critically. And a tool for helping you to do that would be to consider how valid the research is. So your textbook in chapter 3 really emphasizes the 4 validities. You can get overwhelmed with the terminology, but when you're thinking about the 4 validities, I really want you to think about what does it mean to say that something's valid? Because when we're talking about validities, that's what we're really talking about, whether this research is valid. And there are different ways to think about whether the research is valid. So what do we mean when we say valid? What do we mean? When we say that's valid, what is it that we're saying about that thing? You know, we're saying that it's true, that it's based on truth, that it's legitimate, that it's credible, right? That it's able to be accepted, right? So it's legitimate. So when you're thinking about these different types of validities, each one of them is really a different way of asking about whether the research is credible or legitimate. So the first one that's covered in your textbook is called construct validity. And so a way to think about construct validity is, how well is this research measuring what it's intending to measure? If I'm intending to measure self-esteem, but I ask you instead, my measure is asking you how happy you are self-esteem and happiness the exact same thing? Not quite, right? Self-esteem is really about your overall self-worth. That can be a little bit different than happiness. And what do we mean by happiness? Do we mean like happiness in the moment? Do we mean life satisfaction? So it's really important for you to think carefully about what the specific measure is that's being used, and whether that measure is actually assessing the variable that it's intended to assess. A lot of times there's a bit of a discrepancy there. So that's construct validity. And the word construct, it's really just a term that's often used for variable. It's a phenomenon, the construct. It's the idea of the variable. So construct validity is, to what extent are we actually measuring this construct or this variable of interest? External validity is generalizability. So in week 1, we learned about weird samples, or this state of the field of psychology in which most of our research is based on samples that represent Western, educated, industrialized, rich, and democratic samples. So to what extent do weird samples generalize to other samples, to non-Western samples, to lower socioeconomic populations, to less educated populations? When we're asking that question, we're asking a question about generalizability. So in other words, it's called external validity, because you're looking at whether this specific study that I conducted is also valid outside of the population or the sample that I specifically studied. So external to the study itself. Statistical validity. The statistical validity is really it's something that's difficult to assess when we're just reading media articles. You really have to look at the statistics that are used in the research article that's published in a peer-reviewed journal. But it's an excellent way to be thinking critically about research, because there are actually a lot of studies that are published and that are reported in the media showing a significant, statistically significant result in which there's a correlation, for example, between two variables, or there's a causal influence of one variable on another. But if you really look at the strength of that correlation or that relationship, or you really look at the size of the effect in the causal relationship, sometimes the correlation is really weak, or sometimes that causal effect is really tiny. Then you wonder, well, how was it statistically significant if it was so weak or so tiny? And you look at the sample size. Sample size is huge, thousands of participants. In statistics, we call that power. So statistical power is determined by the sample size and by the effect size. And sometimes you might have a really tiny effect, but it looks like it's statistically significant because there are lots of participants in the study. It's a huge sample. And so it has a lot of power. But does that mean that weak relationship, is it really practically significant? Is it really meaningful? So the reverse can also be true. You can have a really small sample, but end up having a huge effect size. Maybe you have a sample of like 8 participants, but this huge difference between, you randomly assign 4 participants to one group and 4 participants to another group, and you have this huge effect size, so it's statistically significant. But because you have so few participants, just one participant, maybe who was an exception, or was like maybe quite far away from the average, maybe really impacted that effect. If you had a larger sample, maybe you will wash out a little bit. So those are statistical examples of statistical validity. One thing that's important to note regarding statistical validity is that in science, and you might even hear scientists sometimes say this, but it's really important. This is something that we agree upon in science. We don't talk about proving anything. We don't ever prove anything. We don't like to use that word prove. In media, you'll see this study proves that. We don't like to use the word prove, because there's always variability. There's always differences within a group. There are always differences between groups, cultural differences, developmental differences. They're human beings. We're unique. We don't always fit the rule. And so there's variability, which means that we are working with probabilities. And so we don't like to say that we prove something, because we could be wrong. We're talking about probabilities. We're talking about patterns. There are always exceptions to the rule. There are always individuals who don't necessarily fit the pattern, which is great. I mean, that's what's exciting about being human. But it's difficult to say in psychological science that we prove something for that reason. And if you remember from statistics, our p-values, right, which determine our statistical significance, our p-values are really the probability that we obtain this result just due to chance alone, or just due to fluke. So we say that something's statistically significant if p is less than 0.05. Okay, but what if p is 0.03? What does that mean? That means that 3 times out of 100, we're wrong. 3 times out of 100, this effect that we obtain, this relationship that we're observing, is just a fluke. It's just due to chance alone. So we don't say that we prove anything. So if you see something in the media where this study proves this, that's a red flag for you. Wait a minute. Let me dive in a little bit deeper and think critically about this before I decide to change my whole diet based on this study, right? Because it's a red flag. It means that something's not being interpreted properly. And then finally, we have internal validity. This is specifically relevant for causal claims. Are there alternative explanations? Now, in the case of correlation, there are always alternative explanations. So if you see that somebody's drawing a causal conclusion, making a causal claim based on a correlation or based on an association, then you know that there are internal validity problems, because in correlation, we can't be sure about the causes. We need to do more research to figure that out. We need to conduct an experiment to figure that out. In the case of experiments, we can look at whether all of the confounds or additional variables that might be impacting our result are also being measured, so that we can rule them out and be confident about the extent to which our variable of interest is having a causal influence on another variable. Okay, so I really wanted to emphasize, those are some difficult concepts. I'd like to sort of practice a few questions with you, and I would like you to think about whether these are making causal claims, association claims, or frequency claims, okay? So here's the first one. Breastfeeding rates hit new high in the United States. Is that a frequency claim, an association claim, or a causal claim? I'll read it again. Breastfeeding rates hit new high in the United States. That is a frequency claim. Why? Because it's just describing the prevalence of a phenomenon in our society. Breastfeeding rates hit a new high. Okay, so they're higher than they used to be. Okay, that's a description. It's describing the frequency. How about this one? Breastfeeding may boost children's IQ. Breastfeeding may boost children's IQ. Is that a frequency claim, an association claim, or a causal claim? Now, they don't use the word cause, but it's a causal claim. If you look in your textbook provides you with a list of potential verbs that are used to make either association claims or causal claims. This statement says breastfeeding may boost children's IQ. That suggests that breastfeeding might have this direct impact, this influence that increases children's IQ. That's a causal claim. So that tells you that that study better have been an experiment. Now, is it possible for that study to be an experiment? Could we randomly assign participants to either have to breastfeed or not? Is it ethical to try to encourage some mothers to breastfeed and other mothers not to breastfeed? Or should mothers feel as though they have the freedom to choose? And if mothers are choosing on their own, then that suggests that there's something about them that's making the choice. We can't actually randomly assign mothers to breastfeed or not to breastfeed. It wouldn't be ethical to do so. So if you see a claim, breastfeeding may boost children's IQ, that's a red flag. Well, wait a minute. If they're making a causal claim, they better have conducted an experiment, but could they randomly assign participants to have to breastfeed or not breastfeed? Is that ethical? How about this last one? Happier families put kids to bed early. This one's a tricky one. Happier families put kids to bed early. Well, it sort of sounds like causal, because they're saying that happier families do this thing, but they're actually not saying that doing this thing is making them happier. So it's really an association claim. They're just saying, well, there are these happy families that are also doing this other thing. Happy families are putting their children to bed earlier. It doesn't say anything about one variable causing the other. It's not saying that putting children to bed earlier is causing happy families, or that being a happy family is causing them to put their children to bed earlier. It's just saying that there are families who do both of these things at the same time. There's an association there. So now, if you're feeling overwhelmed again, every time you're feeling overwhelmed, maybe swearing will help. Also, remember that this is an introduction to research methods class. You're not going to get everything overnight. This is an introduction, and really it takes years of practice for these kinds of concepts to just jump out at you really easily. You know, if you're learning a musical instrument, you don't just learn it overnight. You have to practice and practice and practice and practice. Research is like that too. It's a career. It's a career, and I've been doing it for over 2 decades. And there's still a lot that I'm practicing in research. So it's a lifelong career of practicing. All right. And so, congratulations, you're taking a step towards understanding these difficult concepts. And it's just about practice. All right. So after Psych 290, you'll have opportunities to continue learning about research. And those are all opportunities for you to practice. They're not easy concepts to get. All right, so for chapter 4, when you are learning about ethics, I've posted multiple examples. Your textbook does a really excellent job of reviewing ethics. There really aren't a lot of additional concepts that I'd like to review because your textbook does such a great job. I do encourage you to look at the additional examples that I posted in a folder for you because I want you to see some of the videos. There's like a video there about 5 psychology experiments you can never conduct today, but there's also some examples of ethical violations that aren't covered in your textbook. For example, some of the unethical genetic research that has been conducted in Native American communities not too long ago. It's really important to be aware of some of those examples, especially because they're really not that long ago. So there are ethical violations that are happening still today. And in fact, even within the past 10 years, 7 years, there are multiple psychologists who've been terminated from their positions at prestigious universities like Harvard for fabricating data and making up their data. So even the most prominent and most prestigious psychologists fall prey to unethical behavior. And it may not appear that making up your data would cause harm, but it does, because it has a direct negative impact on the communities that are affected by those research findings. And, we conduct research to ask questions and address questions about issues that we care about. And those understandings, those psychological understandings, impact policy and decision making. They impact the interventions that we design. Our understanding of how we think, feel, and behave fundamentally impacts the solutions that we try to develop to improve lives. So it's important to have valid, accurate, reliable data based on rigorous scientific methodology. So feel free to review those additional examples. Your discussion board, you're going to be watching a video about the Stanford prison guard study and then trying to identify as many ethical violations as possible. And then you're going to state whether you think the trade-off is worth it. So sometimes there is research that's conducted that causes a little bit of harm, but it's for the purpose of acquiring really important knowledge about how we think and feel. So watch that Stanford prison guard study. Is the knowledge worth it? You decide. As a field, we have put measures in place to prevent that kind of situation from emerging again, but I still want you to think about what it means in terms of being able to address some difficult questions about how our mind works. And importantly, in the case of the Stanford prison guard study, how the situation that we're in can influence the way that we behave.